See how you guys are, how good you guys are. Okay, so these are, name this structure and then draw these formulas. Piece of cake? You guys ready to get in your groups?
Yeah.
18 participants. Breakout rooms.
We draw the ones that are written out, correct, Dr. Henry?
What was that? Yeah, you draw the ones that are written down.
Perfect.
Okay, I'll see you guys in a minute. Let's see, you guys can do the diagram or the structure. Okay, so let's start off with the structure. Tell me about this carbon sphere. Can you guys see what I'm making reference to? Can we underline it? Circle it. These guys. Tell me about these guys.
Are you asking like the name?
Yeah, so what would be the name of these side chains?
Methyl and ethyl? Like,
Is it methyl and ethyl?
no. Which one?
The
Like
ones that are
just
circled
one?
in purple. I mean, or in pink, hot pink. Or
Oh, they're methyls, right?
they're
there's
methyls.
one,
Yeah.
Yes.
right?
So I see, what does this say? This says ethyls. Is that correct?
Just kidding.
Just kidding.
Just kidding.
Okay. You're just trying to keep me on my toes, right? You're like,
Yeah.
you
Yeah.
got to keep Dr. Henry, honest here.
Just checking to see if you're awake.
Yeah. Oh, it's funny because I'm like, I had a cup of coffee and it still hasn't kicked in yet. I'm like, man, it's struggling. I had too good of a weekend, I didn't have as much work to do, or I should say I did work, but not as much as I normally do. So, okay. So the next one, do you guys all agree with that one?
Yes.
Are you sure?
Yeah. When you say it like that, you make me doubt myself, but
You guys are
I think-
correct. Yes, that is correct.
okay.
Okay, so let's see these next ones. So the cadmium 4 azide. Yes, we all know that those are subscripts, right? The numbers that are next to them, right? Yeah.
Yes.
Yes.
Even though that they typed them in like that. It's just thank you guys. Trying to be lazy. Okay, so these are correct. This guy here, the N, since there's only a single N, you would actually, I understand why you wrote it that way, but you would actually write it CD. That's kind of tricky. So I guess, yeah, it would be best to write it that way just to be sure, because otherwise you'd get it wrong, because you'd say cadmium, what is the normal charge for nitrogen?
-3.
-3, yeah. So it would be -3, so then you would have 12 of those, so you'd get cadmium some crazy number, right? Or you'd really screw up that way. But yeah, I guess that'll be acceptable. So under the circumstances. So we know that this is azide is a -1 charge. So we'll need 4 of them to balance out that cadmium. Okay, let's see. Calcium nitride, that is correct. Both of these are correct. Let's see, let's see. Ammonium oxide is correct. Good job. Man, you're getting all my curveballs. Good job. The aluminum oxide is correct. 1, 2, 1, 2. I like it. Looks like a little spider. Upside down spider. Diethyl ether is correct. Formaldehyde is correct. Ooh, I gotcha. Al. So that Al root is for which one?
Oh,
Aldehyde.
Aldehyde. So we needed to put 1, 2, 3, double bond. O and an H. Where's my eraser? Oops. Control Z.
Dr. Henry, were we supposed to do pentanol too?
No, that was just left open. I was going to give somebody else the opportunity to do that for us.
Okay.
Anybody volunteering to do that one for us?
I'll try it.
Okay. And let's see. Make me have to travel. Figure out where. Let's see. So many things open here on my screen. Okay, so that is 1, 2, 3, 4, 5, 6, 7, 8. OH. 1, 2, 3. Fibromo. 4. Ethyl. That is so lovely. Good job. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. ISO, perfect. And 1, 2, 3, 4, 5, 6. Double bond. Okay, and that's 1, 2, 3, 4. Ethyl. Good job, good job. Looks great. You guys did a good job. Simple. Man, I'm gonna start thinking you guys go to the tutor or something. And let's see, that's 1, 2, 3, 4, 5. Double bond. Perfect. Good job. Bravo. You guys did a great job. I'm very proud. Very, very proud. Even my curveballs. I only got you on 1, so very proud of you guys. Good job. You guys are ready for the test, huh?
no.
Okay. So now that you've shown me your knowledge in organic and ionic compounds, I'm going to go over, and I know that Jessica went over it with you, but I want to make sure that there's a clear understanding. So do you like the group activities?
Yes.
Okay, so I want to go over covalent bonds, right? So when we're talking about naming covalent compounds, we will often use what we call Greek prefixes. to tell us the number that we have. Now, Greek prefixes are only going to be used for covalent bonds, okay? Or there's always going to be a really odd exception. With 99.99% of the time, you're only going to be using it for covalent bonds, okay? So, let's see. Okay, so you guys are all familiar how we would name this. You guys need to be familiar with all of the Greek prefixes. So we know that there's, let me type them up. My handwriting is atrocious. Mono. Di. What is the one for 3?
Try.
4,
Tetra.
5,
Penta.
penta. 6,
Hexa.
7,
Hepta.
8,
Octa.
9,
Nono.
10.
Dec.
Okay, piece of cake. 11 will be un deca. Okay, so. Okay, so knowing that, the way that we do it is we just tell how many of each of the molecules we have, right? Now, mono is used sometimes, but sometimes it isn't. So it's just kind of flexible. If you just have carbon dioxide, that means you have 1. Okay, so like the first one. What would that be called?
Carbon dioxide.
Oh yeah, right? Okay, and the key is that to tell us that you're at the end of that compound, we put an "ide." So we use oxide, okay? So, and you always name it in the order that it's in, carbon dioxide. And usually the way you set it up is the one that's most electronegative is going to be the one that you put in the back, usually. Okay, so what is this guy called?
Nitric oxide.
You said nitric oxide?
Yeah.
Nope,
Or is it nitric oxide?
Nitrogen oxide.
nitrogen oxide. Or we call it mono nitrogen oxide. What about this one?
Dinitrogen oxide.
Dinitrogen.
Dr. Henry, for the test, do they have to add the mono or can they just leave it like, for example, nitrogen oxide?
Either one would be acceptable.
Okay.
Okay, the next one.
Carbon nitrogen difluoride.
Oops. And the last one.
Carbon dioxide.
Carbon monoxide.
Okay, piece of cake.
Yes.
Now you noticed here, instead of saying monoxide, we just call it monoxide. We drop that O. But you'll notice they'll do that. So if the letter is the same letter, they won't repeat it. So like mono, they'll put monoxide. And although for triiodide, they actually do put triiodide. So, iodide is kind of a weird one. Okay, so let's take a look at this. Let's do um, okay. Then I'll type up some other ones. Four groups. Okay, let's see. Let's put you guys in groups, see if you guys got the hang of this. Ready? Okay. So we'll say, how will we do this? I get the right on Ryan's page.
Are you able to
So
see it, Dr. Henry?
I can see it, yeah.
Okay.
I'm just a little slow writing. So group 1, which is Anna's group. You guys got this one, and we'll give you this one down here. Group 2, which is Kayla's group. Group 3, which is Aaron's group. And group 4, which is Jocelyn's group. Show me those skills. And those are subscript, right? Anna's group?
Yeah.
Yep. Piece of cake?
Yeah.
Everybody agree?
Yes.
Yeah.
Yeah.
Anybody disagree? Everybody understand? Excellent. Okay. So let's get to acids and antacids. But before we do that, let's talk about your polyatomic ion table. How many of you guys have your polyatomic ion table?
I do.
Excellent. see if I have mine. Let's see. Okay, so I'm going to share my screen. Maybe screen 2. So all you guys have these, right?
Yes.
Yes.
Okay, so let's talk about your polyatomic ions. So at this point, you probably have already done the homework. You're very familiar with polyatomic ions. Well, let me just give you a brief summary of them. And they're going to be kind of important for understanding acids as well, too. So your polyatomic ions are ions that are polyatomic, multiple atoms. In most cases, these ions are forming covalent bonds with each other, and they have an additional electron added onto it, okay? So that gives them that charge. So they act as an ion as well as covalently linked to each other. So you'll notice they all have like acetate, ammonium, arsenate, arsenite, okay? So I'm gonna give you some general understanding about how to understand the polyatomic ions. And of course, you have your table here to kind of get you started. But then I'm going to tell you about what we call like our baseline, and then what we do once we start dropping down, okay? So these guys, most of these guys are called oxy and acids. Oxy and ions. Okay, what do you think oxy and ion mean? Anyone? Oxy. Do you want me to type it out so you guys can see the word?
Without a charge, I don't know.
Would they be like ions with oxygen in them?
That's right. Oxy and ions are ions with oxygen in them. Now, if you notice, the majority of these guys have what in them?
Oxygen.
Oxygen, right? So these guys are considered to be oxy and ions. Okay? Simple?
Yes.
Okay. So let's go through it. Now, I'm going to say this now, and I'm going to tell you there's always going to be an exception. But for the most part, you can kind of get an idea of the ion, the type of ion that you're going to form by who it is that you're working with. Like, do you guys all have your periodic table with you?
Yes.
Okay. So, on your periodic table, arsenic. What would be the charge of arsenic?
-3.
-3. Okay. What would be, so if you take a look at arsenate, right? Look at the charge on it.
3-.
Okay. So which is the same thing that you would have for your arsenic. Is that correct?
That's correct.
Okay. So let's look at, let's see. Chloride. What would be the charge on your chloride?
-1.
-1. So if you take a look at chlorate, what is the charge on chlorate?
-1.
-1. Now, if you take a look at sulfide, or on your periodic table, sulfur, sulfide, what would be the charge on a sulfide?
-2.
-2. So if we take a look at sulfate, what would you expect the charge to be on that?
-2.
-2. Does that hold up?
Yes.
Yes. Okay, pretty good so far, right? Now, nitride. What would be the charge on nitride?
3
Negative
minus
3.
-3.
Okay. Now, if you take a look at the charge on nitrate, what is it?
-1.
-1. So that is an example of an exception. Okay. So for the most part, you can kind of use that as leverage. Most of them will obey that rule, right? Depending on the group that they're in, they're going to behave that way in the group that they're in. However, nitrogen is that exception that doesn't do that. Okay. Or the nitrate doesn't do that. Okay. You guys see that? Yes, no, maybe?
Yep.
Yes.
Okay, good. See, you guys, I was trying to get down to the, so you guys can see. Okay, so now let me talk to you a little bit about these anions, and then we'll go into a lot more detail about oxy acids. So let me get to my whiteboard. So you all have your polyatomic ion table, so you'll be able to work with me?
Yes.
Okay, good, good. Get to whiteboard. Okay, so start with phosphate. Okay, 8 is the one that typically starts it out, and usually I always have to use my polyatomic ion table to remember how many oxygens are there. And you'll notice that the oxygens are going to vary from molecule to molecule, but we know that phosphate is PO4 3 minus. Right?
Correct.
Anybody want to argue about it?
Nope.
Good. So if we lose 1 oxygen, we will call it phosphite. And then that's going to be PO3 3 minus. Notice the charge does not change.
Correct.
If we lose 1 more oxygen, we would call it hypophosphite. And then that's going to be what?
PO2 3 negative.
Now, if we gain 1 more oxygen in addition to that phosphate, let's go. We call it perphosphate for like hyper. So how many oxygens do you think that guy is going to have?
5.
Okay, piece of cake? Yeah, no, maybe?
Yep.
Correct. I think that's correct.
Pay attention to the trends. Now I want you guys to do the same thing for arsenate. Who's going to do it for me?
I can do it, Dr. Henry.
Okay.
So with 3 oxygens, it's arsenite. But with 4 oxygens, you get arsenate.
And so what would 5 oxygens be?
So that would be what did we just say? Hypo. I'm sorry, I just forgot everything we just said. Hypoarsenate
It'd be per arsenate, right? For
Per,
five.
per arsenate.
per arsenate, yeah. And then if it was 2 oxygens,
That's hypo.
that's right. Hypoarsenite. Okay, what if we had antimony as our element? So what would we expect that to look like, and how would we name it? Where's antimony?
Dr. Henry, you said Anthony?
Antimony.
Oh, Anthony.
Oops. That should be a 3 there. So what will we name it? At the base, we'll start off at the 8 part. What will be the name of it? Because we call phosphate, since it has a phosphorus in it, it's called phosphate. Arsenate, since it has arsenic in it, it's called arsenate. So what would be antimony?
Hey,
What was that?
it'd be Anthony.
Antinate. Okay. So, and then what would its structure, what would it look like? What would be the chemical formula?
I can't even find Anthony. Is it on the periodic table?
It is.
Okay, I'm blind then.
I found it, Judy. It's number 51.
51?
It's in period 5.
That's antimony.
Isn't that what it is?
Yes. Antimony. Yes.
Oh, I get it. Okay, I'm sorry. It'd be SbO.
SbO4.
SbO4. And what will be the charge on it?
3 minus.
3 minus.
And why is it 3 minus?
Because it's
Negative 3 charge. Antimony does.
It's going to behave just like the people in its group, right? So what group is it in?
Group 15.
Group 15. So it's going to behave just like phosphorus, just like arsenic, although we know that nitrogen is an exception, right? So it's going to have a -3 charge, just like the rest of the guys. Piece of cake?
Yes.
Okay. So,
Phil, that's going to be a test question.
yes, that is going to be a test question. Okay. So let's say we have tellurium. Tellurium. So what would be tellurium's oxyanion for the 8? Where's tellurium located?
52, right next to
52. Who is it going to behave like?
group 16.
Who's in group 16?
Oxygen, sulfur,
Oxygen and who?
sulfur.
Sulfur. So let's start off with sulfur. What does sulfur looks like?
That's so. Oh, sorry. Go ahead.
Let's start with the 8. It's called what?
Sulfate.
Sulfate. Okay, so what does that look like? What is the chemical formula?
SO4, 2 negative.
SO4, 2 negative. Okay, so what about sulfite?
SO3, 2 negative.
What about hyposulfite?
SO2, 2 negative.
So per phosphate is PO or SO5,
That is correct. And what's the charge on it?
-3 or -2.
-2. That is correct. Let me fix my little test there. Okay, so then tell me about tellurium. So if it was forming an oxyanion, what would we expect it to look like? What would we call it?
Tellurate. I don't know how to say it.
Tellurate.
Tellurate.
Tellurate. Okay. And then what's that going to look like?
TeO4, 2 negative.
TeO4. So what is pertellurate going to look like?
TeO5, 2 negative.
Okay. Boy, it seems like I have a class of 3 people. This is the smallest class ever. Just sworn there's 19 people here. What is hypotellurite going to look like?
PeO.
Two negative.
Oops, I forget tellurite. Piece of cake?
Yep.
Yeah.
Yep.
Okay, so you have this beautiful polyatomic ion table. It kind of gives you an idea of what everything is going to look like. So if I asked you hypoborite, what would that look like?
Hypo what again? I'm sorry, what'd you say?
Borite. I'll write it on the board so you guys can see it. Oops.
What's that? BO23 plus?
B O 2. You said 3 plus?
Yeah.
No.
3 minus.
Yeah, so anytime you see 8, it's always going to be a minus associated,
Oh, okay.
right? So you want to see what borate is going to look like. Is borate on your polyatomic ion table?
Yeah.
Borate is
Oh, yeah.
What is it?
BO3 3 negative.
It's BO3 negative. So would it be BO2
No.
if I'm using hypoborite?
No.
Okay, so it wouldn't be BO2. What would it be?
BO1.
It'd be BO, like your body odor. BO.
Mm-hmm. Do you necessarily need the subscript?
Nope. Since it's a 1, we wouldn't have a subscript, right? Because we don't
Correct.
put subscripts for 1, right?
That's correct.
Okay, so it's BO.
3
And what
negative.
will be the charge?
3 negative.
I'm sorry, how do we know that it's O1?
Because it's hypoborite. If borate is BO3, 3 negative, then hypo is dropping 2 oxygens. So then we're only left with 1 oxygen.
Yeah, I see what you mean.
You see what I'm saying?
Mm-hmm.
So you have borate. That's a good question. For my polyatomic ion table, it's BO3, 3 negative.
Mm-hmm.
So then hypoborite is going to just be BO because borite is BO2,
O2.
3 negative, right?
Okay. Got it.
Okay, so this is what I want you guys to do. I'm going to put you guys in groups one more time, and then we'll come back and finish up with the acids. I'm going to erase this. You guys got it? You got it down?
Yes.
Mm-hmm.
Second to get it down. So you see how we did the phosphate? So I'm going to give you a list of ones to do for me. And then I want you guys to kind of explain it to each other, particularly those people who didn't say anything. Okay, you guys ready?
Yeah.
Yep.
See, so these are the ones I want you to do. Again, waste. Just clear. Okay, we're gonna start off with, now be sure to use your periodic table to kind of get you started. There you go. Okay, rooms are open. Good luck. See you in a few.
Hey,
Hey,
Get
Judy.
back.
what was that? What was the exception for nitrogen again?
Is it for nitrogen and magnesium?
Is it?
Not magnesium.
No.
Manganese. Manganese.
Oh, nitrogen.
Okay, are we ready?
Yes.
Yes.
So let's go ahead and get started. So let's talk about carbonate. Okay, we're gonna have breakout room 1. So that was Juan's group. Juan, your group, you guys are gonna show me what carbonate should look like. And then all of its family members. Let's see. And then we'll have bromate. We'll go to Jessica B's group. Jamie's group.
I'll do it for us, ladies.
Okay, Judy's group. Then we'll do, this will be Juan's group again. Jessica B. Jamie's.
I'll do the second one, Ryan.
And
Perfect.
Judy.
You want my group to go twice?
That's right.
Or are you just singling me out there, Dr. Henry?
I'm just singling you out. Oh, you guys have to go twice.
Okay.
And you got to put the other guys in there, you know, like everybody else is doing. Not just the one.
Do we just like squeeze in our list somewhere?
Yeah, squeeze it in.
Okay.
Do like Juan did on the first one. Although I gave him less room than anybody else, so.
Thank you, Dr. Henry.
You're welcome.
Oh, I didn't squeeze in the names. Dang it. How do I, guys, does anyone know how to move the text box? Like I'm trying to put Magnate right under mine, you know what I mean?
I don't think you.
You want me to move it for you?
Yeah, please. Yes, please, sorry. Oh, there we go. Yeah, that's what I was trying to do. Oh, fell down. Right. Um, and then I go.
Okay, let's see. K1 looks good. Oh, except for this right here, your eye. Let me see. Where's my circle? Yep, that guy. Okay. Let's see. That's good. That's good. That's good. That's good. That's good. 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 That's good. Let's see. You guys got the hang of this, it looks like. Okay. Let's see. Okay. So here, this one is kind of a gotcha type of one. So this one that you called hypobenzonite. So it can't go below, if it has an oxygen, it has to have an oxygen to have an ite in it, or something similar to an oxygen like a sulfur. Okay. So for this to be used, you have to use, it has to have an oxygen in it. So you'd stop at this point. So this will be your last one.
So there is no hypobenzonite?
Yeah, there's no hypobenzonite.
Okay.
Okay. Okay. Guys got manganate, that's good. Okay, so yeah, this one is also set you up one, because it's your permanganate is correct, manganate is correct, and then manganite, right? Actually, after this point, you can start dropping the O. So you still keep the charge, so it'd be -2, and you just drop the O on it.
So this charge stays at -2?
Yeah. And you just drop your O.
Okay.
So it would be 2, and then you just start dropping your O's. And then hypermanganite would be still 2. Yeah, and this is a weird exception right here, the permanganate.
Okay.
Okay, let's see. For silicate. Okay, looks good. Just make sure you want to put these guys a little lower so we know that they're subscripts. Okay, so let's see you guys use them in the context of polyatomic or ionic compounds. Everybody get this so far?
Yes.
Okay. Okay, let's Let's see if I can move everything without losing it. Okay, so the names, draw the compound, the formulas, write the names.
Can you say that again, Dr. Henry?
I said the ones where I have the names, write the formulas,
Okay.
and then the ones that I have the formula, write the name.
Okay.
Okay, and then we'll share. So there's one thing that I want to say though. So do you guys remember your diatomic molecules? Or your diatomic? Yeah.
Yeah.
Yes.
Something about beer. Yeah.
Yeah. Have no fear of ice cold beer.
Mm.
So there is one ion that is diatomic, and that's mercury. So mercury always has to be written, mercury 1 always has to be written Ag 2 plus. Okay. So and this is the mercury 1 ion. So the mercury 1 ion is diatomic. Oops. So add that to your diatomics. Okay, so who am I going to pick on? Let's do this is going to be going to go Leslie. Then we're going to go with Anna. Then we're going to go with Selena. Then we're going to pick on who are these people? There you go, Judy. Andra. Jessica B. Bless you.
Thank you, Dr. Henry.
Let's see. Oh, I'm looking like I'm very sexist here. Matt and Ryan. Okay.
Perfect.
Show me those skills. He sounds like he's anxious to share.
You've been acting crazy all morning. So I've been on mute most of the time.
He gets excited about chemistry, I can tell. Gotta get him started early.
So we can
I
go ahead and
guess so.
annotate your screen already, Dr. Henry? Is that okay?
Yeah, you can start writing on my screen.
Perfect.
Yeah. Judy, I'm sorry. I should have told you. I didn't set yours up right. I forgot my Roman numeral.
Okay. Sorry.
Let me fix it.
Okay. Can you erase mine?
Yeah, I'll erase yours too. Oops.
Okay.
Oops. There we go. Job. Good job, Jessica B.
Did I get it?
Yes, you did.
Awesome. You can thank Judy. She helped me with that one too.
It's good.
Help me with mine.
Where are you? Where's your? Which
No,
one?
just kidding. Give me time. Give me time. I'll get it. I'll get it.
Got it.
Okay, Deandra, think about the charges. What is going to be the charge on the 10?
The charge on the tin,
Yes.
it's going to be a negative or +2.
It's going to be +2. Are you sure?
-4.
It's going to be -4? 10.
Really confused.
So 10 is a post-transitional metal. So
Right.
it acts like a metal. And then the fact that I have VI there should tell you something. What does that
6.
tell you? That's right, that it's 6.
Right. So where I had those 4s, that's where the 6 would go?
No. Well, the
So
second,
the
well, it
tits.
depends. So what is so per bromate is what? What would be the chemical formula for the per bromate, and what would be the charge associated with it?
Okay, wait 1 second. Let me add the. I wouldn't have to add the 6 by the 10.
No,
Or
you
would I?
wouldn't. No,
Oh,
because
because it would already
you're saying that
automatically.
that's right. You're saying that the 10 is a 6 plus. So you
Right.
need to balance that out with your per bromate. What is the charge on per bromate?
Bromine. It would be.
That would be incorrect.
Wait, were you talking to me?
No, Selena.
Okay.
Yeah.
So for bromine, it would be -1.
Okay. So then how many of those would you need to balance out of +6?
-5.
How many?
-5.
-5. If each one is -1, how many of them are you going to actually need to balance out a +6? Total. So you're telling me that if you put a 5 here, right, that would give me, you're telling me I need -5. So 6 minus 5, does that equal 0?
No.
So then how many
No.
will I need?
6.
I need 6.
Right. So it'd be SNBRO6.
No, because what is per bromate? What does per bromate look like? You needed to do this first. Tell me what that looks like first. Bromate looks like what? And then tell me what per bromate looks like. The formula of per bromate would be what? Based upon your polyatomic ion table.
Bromate is BRO3.
Okay, so then per bromate would be what then? That would be the formula for per bromate.
Would it be BRO?
Per, hyper. That's what the per stands for, hyper. So BRO what?
4 negative.
Okay, would that be 4 negative?
Ooh.
Repeat that, please.
I said, would it be 4 negative?
No, because you said it was a -4, right? So, but how
Right.
many oxygens should you have if it's per bromate? Per bromate means you do what? What do you do when I put per in front of something? It means what?
You're losing.
Am I losing? Okay, so if I look at
No, you're adding.
adding what? What am I adding?
You're adding an oxygen?
I'm adding an oxygen. So normally I have 3, now I add 1 more. So it should be Br what?
It would be BRO. If it originally has 3.
I'm sorry, I'm losing you. I can hardly hear you.
Oh, I'm sorry. Can you hear me now?
I can hear you now.
Okay, so it originally has 3.
Yep.
So it'd be 3.
So, but the per means we add 1 to that 3, right?
Right.
Okay, so then how many will I have?
BRO4 negative?
4.
Or just 4?
Okay, so PRO4. Each one of those have what charge associated with it?
A negative.
A negative, right? So then how many of those will I need to balance out 10, 6?
4.
6.
Okay, so let's talk about the 6. That's right. 6 would be the correct answer because this is 10, 6. VI is 6, right? So that means I'm saying that 10 is SN plus 6 plus, right? That's what I'm saying. So then in each one of those we know is a minus. So I'll need 6 of those to balance it out, right? Because each one is a minus. So that's 1 minus. So I'll need times 6 to balance it out. Okay, so it's SN BRO 4 6. So you're on the right track. Only thing you have to remember that this was,
Dr. Honey, for iron, would it be Fe and then in parentheses CO2 and then 6?
So Fe, you said CO2, and parentheses 6.
Yeah.
That would be, no, what would be the charge on it? What's the charge on your CO2? So what is the charge on carbonate normally? So we just had carbonate. What would be the charge on that?
2 negative.
It would be,
Oh, it would be 3. Right?
okay. So it would be, so you said 3 of them? Okay. And then here's the other thing. So how many oxygens does carbonate have?
3.
It has 3. So if I have hypocarbonite, nite means I subtract 1, hypo means I subtract another 1, right? So if I had 3 initially, how many should I have now? So if I have 3 minus 2,
1.
so I should have 1 oxygen. You see that?
Yeah.
Okay.
Dr. Henry?
Yep.
I'm kind of struggling on this one because, like, I know SeO3 is a polyatomic ion, but when I look at my chart, it doesn't come out.
Okay. So you tell me what group does selenium? What group is selenium in?
16?
It's in group 16. Who else is in 16?
Sulfur?
Okay. So what is sulfur? What is SO3 called?
Sulfite?
Sulfite. So then what would we call selenium then?
Selenite? Selenite? Or
Selenite. That's right. We'll just erase your, oops, all right. Yeah. I guess I can't erase, I have to erase the whole thing. We'll fix it.
Yep.
So then it's silver 1, selenite. Is that what you're telling me? That? Selena?
yeah, I'm here.
You know, that wasn't even on purpose. Okay. So now the thing is about silver. Silver 1 is its most natural state ion. So in that case, you don't have to say silver 1, right? I won't take it off on you, but you'll notice that some questions that are multiple guess, they'll just say silver chloride, and it's understood to be 1. Okay. So since it's already understood, you don't necessarily have to put the 1 there.
Okay.
Okay.
Yeah.
So I'm gonna, just so we stay consistent, erase this one.
So Dr. Henry, the whole SeO3 is all selenite, right?
Yep.
Okay.
Yeah. Okay. And you want to remember that. Remember, they're called oxy and ions, right? So that's what gives them their special names. Okay. So you don't want to mistake those for polyatomic. I mean, just covalent bonds, right? So they're polyatomic ions. You don't want to mistake your polyatomic ions for your covalent bonds. They're different.
Okay.
Okay.
Yeah.
And let's see. Silicon. Okay. Okay, Judy. what would be the charge on siliconate? I mean, per siliconate.
For silicate,
Per
That'll
silicate, sorry.
that's a -2 minus charge, right?
It is a -2 charge,
Right.
right? So
Right.
why would you need 4 to balance out your tungsten 4?
Because I would need 4 of the persilicates because they already gave me the charge of they already gave me the charge of the tungsten right there,
Which is +4, right?
which is +4, right?
So how many will I need to balance it out? Will I need 4 to balance out 1 tungsten?
You would need 4 to balance out 2 tungsten.
Yeah, but I'm not asking you for 2 tungstens. I'm just saying 1 tungsten.
Then see, that's what I got stuck on. Like how I did it. Can I write what I did?
Yeah, I know, I'm pretty sure I know what you did, but I want you to think simpler, right? Because what you have written there would be different than what I'm asking for.
Yeah, and I wrote the formula that I wrote it in words. I'm like, that's not the same.
Yeah.
So, okay, think simpler.
Yep. Think
Okay.
simpler.
Okay.
Okay, Matt, where's polonium?
Polonium is under sulfur.
Okay.
Selenium. So it's got a -2 charge.
Okay. So would I call it polonium tetraoxide? This is very similar to Selena's problem. Who's it going to behave like since it's under?
Would it be polonite?
Polonite, yes. But would it be polonite or would it be polonate?
I don't know. I'm kind of getting stuck, Dr. Henry.
How many oxygens do I have?
4.
Okay. Who else is in that family that has 4 oxygens? Or in that group that would have 4 oxygens? Look above the polonium.
Oxygen.
Okay. Other than oxygen.
Sulfur.
Sulfur. So what do we call sulfur if it has 4 oxygen attached to it and a -2 charge?
Sulfite.
Is it sulfite? IT? Take
You
a
said
look. With 4 oxygens.
Sulfate.
Okay, so then what would we call polonium then? If it has polonium and 4 oxygens and a -2
Polonate.
charge? Polonate. Yep. See if I can. So your nickel happens, your nickel happens to be right, but normally we would put a Roman numeral, right? Just so happen nickel's natural state is nickel 2, and so you can get away with just saying nickel instead of saying nickel 2. So nickel and zinc 2 is its natural state, nickel is its natural state. So you can just get away with saying those, but it's both of them are 2. If they're different than that, if it was nickel 4, it would be wrong. You understand?
Okay.
So you want to pay attention to that. Those are transitional metals or post-transitional metals. They always have to have Roman numerals. Okay, so why doesn't Ryan need a Roman numeral? Is it because I like Ryan better than everyone else?
Is it because it's only 1?
No. Where's strontium located at?
Neutronium has a +2 charge.
It has a +2 charge. It always has a +2 charge, right?
Mm-hmm.
So it's never going to be anything different than +2. It's not a transitional metal, right? So we don't have to put a Roman numeral behind it. So those are important things to remember. When and when not do you use a Roman numeral? You guys get that?
Yes.
Okay.
So Dr. Henry, nickel's a transition metal, yeah?
Yes.
And so we really should put the
Yes.
Roman numeral
So-
2 behind the nickel, yeah?
That's right. And so most cases you would put Roman numeral 2 behind it because it'd be a Roman numeral 2 in this case, right?
Okay.
However, like I said, most of the ions of nickel is 2 plus, right? So it's kind of understood. So you could get away because that's the common way of doing it. That's the same thing with the silver. If it's a deviant from that, let's say it was nickel 4 or nickel 6, then you would have to use the Roman numeral. Here you could get away with doing it or not doing it. So you could have went either way. Do you understand? And they're just, there's only a couple of them that you have to remember. Zinc, nickel, and silver.
Just those 3?
Yeah, just those 3. The other ones, everybody else, you pretty much put Roman numerals behind all the time. Okay.
Dr. Henry, so was mine correct?
Yes, yours is correct.
Okay.
Yep. Because those, strontium is not a transitional metal. So you never put on the alkali and alkaline metals, you never put Roman numerals. Never, ever.
Mm-hmm.
Okay.
Oh,
You guys get that?
yes.
Dr. Henry, is that the answer to question 1?
What about question 1?
I said, is that the answer to question 1? The FeCO3.
Yeah, FeCO, yeah, 3, yeah.
Did I do mine right?
Did you do yours right?
Yeah.
Nope.
Still?
Still?
Okay. I tried thinking simple. That's as simple as I thought, so.
So what is the charge on silicate?
It's 2 minus.
Mm-hmm.
It's 2 minus. Per silicate is what?
SiO. Oh, per silicate is SiO4, 2 minus.
Okay. So, and then this tungsten, what would be the charge on the tungsten?
A 4.
It's a +4. So how many per silicates will I need to balance out the tungsten?
2. So the subscript outside the parentheses would be 2.
That is correct.
What the fuck, dude? Oh my god, I'm so sorry. Sorry. I'm so sorry. I'll shut up. Let me mute myself.
So piece of cake, right? So you guys just have to remember, just like when you had just a monoatomic, you just got to balance it out. At the end of the day, it has to add up to 0, right? And so you want to pay attention to the charge on the polyatomic ions. And then those that are in groups are going to behave the same, except for who? Who are going to be my exceptions?
Zinc, nickel, and silver.
Okay, zinc, nickel, and silver, yes. There's some other ones. So for polyatomic ions, which are the exceptions for polyatomic ions that aren't going to behave like their group?
Nitrogen.
Nitrogen. And then what is another really crazy one?
Mercury.
Manganese or
Mercury and manganese, yes, the permanganate, remember? Okay. Questions, concerns? Cash?
Hey, Dr.
Ready?
Henry,
Yes.
was it so wrong? It was wrong because I already answered it. When I wrote it out, when I had the W subscript 2 parentheses per silicate.
That's right. Yeah.
Yeah. Okay, yeah.
Yeah, it would be wrong because that's a different compound and it will behave differently.
All right.
Dr. Henry, will you repeat that one more time? You said exceptions for what? For nitrogen, mercury, and what else?
So nitrates, so your nitrates, your nitrites, all of those are different. They're not going to behave like their group, right? Because who's under nitrogen?
Phosphorus.
phosphorus. So phosphate has a what charge?
-3.
And nitrate has a what charge?
Minus charge.
It has a minus charge, right? So a -1. So it doesn't, nitrogen is an exception, or that nitrate is an exception for not behaving like its group members. Okay? Do you understand that?
Kind of.
What do you mean by kind of?
Like, I don't understand it all the way. Like, I need to read it a few more times before it sticks.
Okay. So let's see. Before we go, periodic table real quick. P table. Okay, so group members, people that are in the same group, they're going to behave very similar to each other, right? So phosphorus and arsenic and antimony are all going to behave alike, but in terms of the oxygen and ions. Nitrogen isn't. So nitrate has a -1 charge. Phosphate has a -3 charge. Do you see the difference between the two? So if you take a look at your polyatomic ion table, pull that up too. So here's my polyatomic ion table. Can you see both? The polyatomic ion table?
Okay.
Okay, so let's look up nitrate.
Okay.
Okay, you see it?
NO3 negative.
It has a negative charge, right? NO3
Okay,
negative. And it's also NO3, where phosphate, where's my phosphate?
Where phosphate has the -3 charge on the periodic table and on the polyatomic chart.
That's right.
Okay.
Yeah, that phos, yeah. So phosphorus has a -3 charge and phosphate have a -3 charge.
Okay, I understand now. I'm sorry.
That's right. It's okay. Sometimes it's just not, you're looking at two different things and it just doesn't click until.
I was going to say, I've got too many papers in front of me. I've got too much going on in front of me.
That's chemistry. Got to get used to that. Okay. So the next thing I want you guys to think about, and I know we're over time right now, but I want you to listen to what I'm going to say to you. On the side, Jessica was so nice to write that little anagram. I ate organic apples despite them being poisonous. And then my ride has hydraulics. Okay. Now I want you to look at that and you see what's underlined. Okay. So I'm just going to say this real quick so you guys know what it stands for. Okay, can I erase this real quick?
Sure.
Yeah.
So I ate organic apples. Let me see. Ate. Ick. So when we name assets, we take a look at what is going to be the anion that's going to be generated from that acid. So for instance, if I have phosphate, if I can spell phosphate, then I'm going to have phosphoric acid. Okay, so phosphate, we know that it looks like this. Phosphoric acid looks like this. So we have the hydronium, this H plus ion, is going to be balancing out the polyatomic ion. And you want to put AQ, so we remember that it's an acid. It's in an aqueous solution. Okay, so what happens in this case is that we have 3 H pluses. Remember I told you hydrogen is kind of like weird. So it actually will form what we call the hydronium ion. And I'll show you what the hydronium ion actually looks like, but often just that H plus, the hydrogen cation, or we'll call it a proton, is just an H plus, right? And it's going to come together with your phosphate. And we're going to need 3 of those to balance it out. So we have H3PO4. So phosphate plus 3 hydrogen ions will give us phosphoric acid. And vice versa. It can be broken down, which happens in solution. Okay. I'm going to introduce you to equilibrium too, same time. The equilibrium means that both reactions can happen, and they get to the point where they're both exist at the same time, but one may be favored over the other, and we'll talk about that a little bit later. Okay, so we have this case, right? And then we have what we call 8 organic apples, despite, so that IT, despite them being poisonous, OUS. Okay, so if we have phosphite, copy this, so I'm lazy, maybe. Okay, if we have ITE, we put OUS and acid. So what does phosphite look like?
State.
Phosphite looks like what?
CO3 to the 3 negative.
So then what would you think that phosphorus acid is going to look like?
H3 PO3.
Yeah, throw that HQ down there.
Yeah.
The HQ signifies acid, correct?
Yes, it says it's in an aqueous solution, but that's how basically all acids are. They're basically gas that has been bubbled up into that solution, or they're so that they stay in solution.
Okay.
So if I just say H3PO, then you would name it differently, right?
Mm-hmm.
Because that doesn't mean that it's an ion. You would call that trihydrogen phosphorus trioxide. Mm-hmm. So they're different from each other.
Okay.
Okay, so if I said this is a covalent bond, this here is an ionic bond. Okay, special ionic bond. So acids are just a special case of ionic bonds. that are using the hydrogen ion. Okay, you guys get that?
Dr.
So,
Henry,
yes.
on Chem 101, it doesn't give them the option to put aqueous for the acid name. Just a heads up.
Okay. So that's that's because in most cases, are they asking for an acid? Did
Yeah.
they say this acid? So then it's understood that it's an acid. Otherwise, you have to distinguish. Like on your exam, you want to be sure to distinguish. So I'll talk to them about that. I'll email them about that.
Okay.
So yeah, anytime that they say an acid, it's understood to be an AQ. If they say a gas, if they say, so what would be the chemical formula of trihydrogen phosphorus oxide gas?
H3P.
And that they're different, and you need to understand that they would be different from each other and how they're going to behave. Okay, so now think about that, okay, and think about how is it going to play when you put hypo and per and all of that stuff. So how do you think that that's going to affect things?